Welcome to this mini tutorial on velocity time graphs. This is for GCSE, so it's going to be velocity time graphs or speed time graphs. Let's look at this first example. We've got a velocity time graph. We can see the maximum velocity is 4, and we can see it goes over 6 seconds. Well, one thing we might be asked is what's the acceleration? So we might say, well, the acceleration over the first little section, that's from 0 seconds to 2 seconds. Well, as we will remember, I hope from your lessons, the acceleration is the gradient of the graph, the change in velocity over the change in time. So the acceleration is going to be 4 meters per second over 2 seconds, which would give me 2 meters per second squared. So it's an acceleration of 2 meters per second squared. Now you might be asked, how far has it travelled during the 6 seconds? Now the distance it has travelled is the area under the line, the area under the graph. So all of the space underneath this line. Now that, as you can see, is a trapezium. So we work out the area of the trapezium. So it's going to be half the top, which is 2, plus the bottom, plus 6, times the height, which is 4. So 2 plus 4, that's 8. Half of that's 4, times 4. The distance travelled, as represented by this graph, is 16 meters. So the key thing here to remember is acceleration is the gradient of a velocity time graph, how steep the line is, and the distance travelled is the area underneath the line. A couple of other points. You can see it's accelerating here, it's getting faster. It's a flat line there, there's no gradient, so that means it's a constant speed. And here we're getting slower, and we eventually come to rest. When we say rest, we mean 0 meters per second. It's stopped. Well, let's have a look at this example. Well, we've got some times there. It's a 6-second journey. We're told, well, the distance travelled is 40 meters, but we don't have a maximum velocity. We're going to try and find this. Well, we can do this using the area. So let's have a look. We know that 40 is going to equal half the top, which is 2 seconds, I think, 2 seconds, plus the base, which is 6, times v, which is the height. So 40, having a bit of trouble there with the pen, 2 plus 6 is 8, 4v. So I can say v there is 10 meters per second. So the point of this is, if you are given the distance, you've got a graph, you're going to have to somehow create an equation using your knowledge of area to find the missing variable. The missing variable in this case is v, which is the velocity. So I can fill this in. So there, that's going to be 10 meters per second. That's going to be 5. That's a typical example, and I hope that is helpful.